3-3 rotations. So example 1, how can you perform a 75-degree rotation of XYZ around point P? Okay. So you would need to find the measure of 75 degrees around XYZ. Okay, so again, you would be using a protractor to help you identify the degree here. So we want to find the distance between Y and P. And then we would be rotating that 75 degrees. And I'm just going to kind of eyeball 75 degrees because I do not have a protractor that will fit on this screen. Okay. All right, so this would end up being Y prime. I'm going to do the same thing for Z. So this is my original Z. I would be rotating it 75 degrees. Distance would be the same. So it'd be Z prime, and then X. Okay, so I would rotate that 75 degrees. Okay, again, you would be using a ruler and protractor to help you with these measurements because I don't think mine is right at all. Okay. All right, so you would get your rotation looking something like that. Okay. Next, we're going to look at our try it. Do you think a rotated image would ever coincide with the original figure? So in order to coincide with the original figure, it would have to rotate 360 degrees exactly. Okay, rotations. Okay, so a rotation is a transformation of a pre-image around point P by a certain angle measure. Okay, so P is always the same as P prime. Okay, and if we have a positive angle measure, we're always going to move counterclockwise. Okay, to make it a little bit simpler when we're dealing with rotations in a coordinate plane, we have a couple of rules to simplify this. So if we are rotating by 90 degrees, we are going to flip our X and Y and turn our Y negative. If we're rotating 180 degrees, we are going to leave our X and Y in the original position, but make both of them negative. If we are rotating 270 degrees, then we are flipping our X and Y and making our Y negative. Okay, so again, those will help simplify some of our rotations. Okay, so they tell us that we are rotating 90 degrees about the origin. And we have A, B, C. We need to find the rotated image. Okay, so we have our original points we need to identify. So A, B, C, D. So 3, 5, 1, 7. C would be -2, 4. And D would be 2, 1. Okay, again, to rotate these 90 degrees, our Y will become a negative and flip to the first position, and our X stays the same. So we would end up with -5, 3, -7, 1, -4, -2, and -1, 2. Okay, now I can graph these and see what it looks like. Oh, and I can tell that my D is not correct. So if I plotted that, that is not going to be the right point. So I need to look and see where I messed up. So this actually should have been a negative right here. So that should have been -1, which means that this would become +1 here. So now when I graph this, 1, 2 would be right here for D. Okay, so that's what my rotated image would look like. Right, let's look at the try it. We're given our original 3 points, and we need to rotate 180 degrees and 270 degrees. Okay, 180 degrees, we leave our X and Y in the same position, but we make both of them negative. So X prime, all I'm doing is making both of these negative. Y prime, 0, -8. Z prime, -2, +1. All right, B, we're rotating 270 degrees. So X prime. All right, so if we're rotating 270 degrees, we're flipping the position and making the X negative. So this would be 7 and +4. Be 8 and 0. And -1, -2. Okay. All right, example 3. The first drummer in a drum line is at the 20-yard line, and the sixth drummer is at the 35-yard line. The drum line rotates clockwise 180 degrees about the sixth drummer, and then rotates 135 degrees counterclockwise about the first drummer. Where does the sixth drummer stand after the rotation? So let's kind of sketch this out. So the first drummer is at the 20-yard line. So the first drummer would be right here. Okay, and the sixth drummer is at the 35-yard line. Right there. All right, the drum line rotates counterclockwise 180 degrees about the sixth drummer. Okay, so they are rotating 135 degrees about the sixth drummer. Okay, so if they're rotating 180 degrees, this drummer, or this line of drummers, would be rotating. My sketch is not the best. Like this, and would end up over here. So this is a 180 degree rotation here. We'll call this A, B, so this is going to be B prime. Okay, because we rotated around this sixth drummer, the A is also just A prime because that drummer did not move. All right, so after that first rotation, then we're going to rotate 135 degrees clockwise about the first drummer. Try to find a different color. Okay, so we're rotating clockwise about the first drummer. So this drummer is now going to be holding everyone's center, and then we're rotating 130 degrees. So we're going to say roughly right there. So this would be A prime prime, and this would be B prime prime. Okay, so the sixth drummer is going to end up standing at A prime prime. Okay, and then our rotation composition. We rotated 180 degrees about A, and we rotated minus 135 because we went clockwise about B prime. Okay, let's look at our try it. Suppose the drum line instead turns counterclockwise about B prime. How many degrees must it rotate so the sixth drummer ends up in the same position? Okay, so to end up in the same position, they would have had to have gone 180 or 360 degrees fully, but they have only gone 135 so far. So we would take 360 minus 135 to find out how far farther they need to travel, so 225. All right, can the composition of rotations be described by a rotation of 45 degrees about A, since 180 degrees minus 135 degrees is 45 degrees? Okay, that would not work because there are two different centers of rotation, so we can't just simply say 45 degrees around A because we also had the rotation around B prime. Example 4, can you find the sequence of reflections that result in the same image as a rotation? Okay, so they're wanting us to find a sequence of reflections. So if I was to just reflect across, let's say a line right here, if I reflect it directly across, I'm not going to get that same image, JKLM. It's not going to be the same as XYZW. Okay, so we need to find a series of reflections that will get us to the JKLM. Okay, so if I start with a reflection roughly right here, it's going to reflect directly across. I need to create perpendiculars. Okay, so there's one reflection. And again, these are just kind of simple sketches, not the best. If I was trying to be accurate, I would get a ruler out and measure to get these a little more accurate. Okay, and I can already tell this one I did not draw right. I think it should have been back here. Again, if I wanted to be more accurate, I should have used a ruler. Okay, but we can see essentially it would be possible we would have to use a series of 2 reflections to create the same effect as doing a rotation. Okay, perform the same construction shown except draw a line P so that it does not pass through T. Do we get the same result? So let's kind of sketch this out. Okay, this time I'm going to start with JKLM. We're going to reflect, but we don't want it to pass through T. So I'm going to create my line of reflection here. And then we're going to try to sketch this out. Okay, so I can see that I am not going to get the same images if I don't reflect it through, or if I don't put my line P through T. So this would be line P. If I don't go through T, it's not going to create the same reflection. right, rotation as composition of reflections. Okay, any reflection or any rotation is a composition of reflections across two lines that intersect at the center of the rotation. The angle of rotation is twice the angle formed by the lines reflected. So here we have our original angle, and we are splitting it with two lines, M and N. And M and N, the degree between those is half of the entire degree between A and A prime. A prime prime. Okay, so we need to prove the rotation is a composition of reflections across two lines. And we need to prove that there are two lines, M and N, that will create this reflection. Okay, so if I create a line of reflection here, let's do a solid line. Okay, so I've got my line of reflection. This is M, and we are reflecting A across it to get A prime. The degree that we create between A and M is angle A, has to be congruent to this angle A. If I create another line of reflection here, let me do a solid so I can stay consistent. This would be N, and the degree of my angle for these two is also congruent. Okay, so my measure of angle X has to equal A plus B plus B. Okay, so we need to put a point B that is closer to point A, or point Q that is closer to point B. Okay, so we're going to put a point Q. It's going to be closer to point B. So that's my line M. So when I reflect B across M, I end up roughly right here, so B prime. And then I need a second line of rotation in, which will reflect and give me B prime. Okay, so we can put Q anywhere. Okay, so we can put Q anywhere, and our angle between the lines of reflection will still be half of the angle of rotation.